We are still on data analysis. So I want you to do the question I gave you. I asked you to analyze. Can somebody give me a question? Anybody? Question I gave you. Yes, the assignment. Under decision and accuracy. Yes, please wait. Perfectly, yes, perfectly. Okay. 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 Yes, continue, yes. Under A, BBA. Yes. Yes. Okay. Then student B. Yes. Okay. All right. So, continue. If the true value is what? 3.08. Yes. Yes. Absolute error of one student, yes. Relative error of both students, yes. Percentage relative error of both students, yes. Standard deviation of both students. Okay. Yes. Okay, yes. Which student is more accurate? Yes. Then two is more precise. Yes. Thank you very much. Thank you so much. So, to find absolute error, relative error, percentage relative error, we need to get the mean of this data. So, firstly, what's the mean of data A? What's the mean value of data A? Mean value of data A. Mean for A. We just add this. So that will be 2.84 plus 2.92 plus 2.81 all over 3. That's the mean value. That's the mean of the result that A presented to us. That's the mean of the result. What's the answer? 2.886. Okay? Now we have to find absolute error. Absolute error is true value minus mean of the data. What's the true value? 3.08 minus, and what's the mean value? 2.86. Good. So the answer is what? Anybody? 2 point. That's the absolute error. It's a positive. The absolute error is always a positive value. Even you say 2.86 minus 3.08, you must report the answer as positive. Absolute error. In the word absolute must always be positive and never negative. Relative error is absolute error. Is absolute error all over true value. All over true value. That is absolute error. And that's relative error. And that's 0.22 all over. What's the true value? 3.08. So that's what? What's the answer? .07. That's the relative error. Percentage relative error. Percentage relative error is simply relative error. Relative error times 100%. That's percentage relative error. Our relative error is 0.07 times 100, and that's what? 7%. That's 7%. Your mean deviation, you have done this, you've done this, you've done this. Let's get standard deviation. Standard deviation of the error. The standard deviation is what? The square root of summation x minus x bar all squared all over n minus 1. Why is it n minus 1 and not n only? Why is it when n is less than or equals to 5, you must apply n minus 1 here. But if n is more than 35, you apply only n. Is that okay? So your standard deviation is now equals square root of summation x minus x bar all squared. So the question now is, I'm going to do this minus this square, this minus this square, this minus this square. That's the degree of x minus x bar. And we'll now sum everything. Let's do it. That's 2.84 minus x bar plus x bar. 2.86. Square the answer. I will add plus another one. Next one. 2.92 minus 2.86. I will square it. Then I will add again. 2.81 minus 2.86. I will square it. All over. What's our n? What is n class? N is 3. Because there are only 2 data presented by the two students. This is 3 minus 1. N is 3. So this becomes square root of, please tell me. Please tell me. What is 2.84 minus 2.86 all squared? 0.1. 2.84 minus 2.86. That gives us 0.0. No, how is 0.2? 0.0. I mean that. Plus 2.92 minus 2.86. What's the answer? 26. Am I correct? Plus 2.84 minus 2.86 all squared. Four to 5 all over 2. Here, please. Okay. This plus this all over 2. What's the answer? Have you divided by 2? 0.00, yes. 325. Now find the square root of this. 0.057. That is standard deviation. That is standard deviation for students A. The mean deviation. I'm still on student A. Student A. What's the formula for mean deviation? Summation x minus x bar all over n. And that would be what? That would be this minus this. That is 2.84 minus 2.86. That's this for the first one plus 2.92 minus 2.86. That's for this. Without putting square. Don't put square in. Plus 2.81 minus 2.86. Do not put square. Everything over what? 3. That's the mean deviation. So tell me, what is now the answer? 0.043. That's what we need. So copy all these answers down. So for A now, let's watch it again. So for A, let's watch class, please. Let's watch. The relative error of this percentage relative error. Percentage relative error for A is what? What do we get? We got 7%. Why the standard deviation? Standard deviation for A. What did we get? 0.057. Let's keep this. This is for A. These are the two values we use to determine. We use this value to determine who is more accurate, who is more precise. Shall we go to B now? Should we go to B? Okay, please, yes, go ahead. Yes. No. Yeah, I know what you're asking. You are trying to test the rule of rounding off. Am I correct? Yes. You will not apply the rule of rounding off in anything you do unless they test it intentionally. You get me? You don't have to test it. I've taught you, I've let you know when this is tested intentionally. When they gave you mass, they gave you volume. They will even give you the formula to calculate density. Do you get me? So, in that case, you know they are testing the rule for rounding off. If you are basing on rule of rounding off, yes, it should be 0.07. Is that okay now? Because after all, these are in the same number of decimal places. Is that okay now? But we will not apply the rule of rounding off in everything we do. No. Is that okay? But yes, it's a rule of rounding off, and that will be tested intentionally. It will be tested intentionally, or you sense that they are testing it in the option, like in the option now. What you have asked is a very good question, and I love that. In maybe the option, they ask you to find this only. You now put option 0.07. You now put 0.071. You now put 0.0714. You now put 0.0714. Next number. I don't know the next number there. If you now put the answers like this, then flashback on the rule of what? Rounding off. Is that okay? Thank you. Thanks for reminding us on the rule of rounding off. That's very good of you. Okay. No, you can't get minus. Everything you do here must be absolute. We say summation x minus x bar all over n. If I gave you 2.81 minus 2.86, you must report this answer as plus, even though it is minus. Is that okay? Very good. You must report this answer as plus, even though it is what? Minus. Deviation does not have business with plus or minus. Deviation has no interest in plus and minus. Deviation is simply deviation, meaning it's different from what it should be. By how much is it different? I don't care the sign. I don't care about the sign. You are supposed to measure. Yes, please. I'm listening. Okay. Now, one of the best, in fact, the best measure of dispersion. Listen about it. The best measure of dispersion is coefficient of variation. Is that okay now? At least to your level, okay? To your what's it called? To your mass level now. The best measure of dispersion is coefficient of variation, and the coefficient of variation is standard deviation all over what? Mean. That's the coefficient of variation. Standard deviation over mean. Therefore, the best way to test precision of a data is to use standard deviation and not what? Mean deviation. Now, in standard deviation, if your data is not that much, possibility of errors are bound. Is that okay now? But if your data are well scattered, if you have more, the more you collect, the more the data you collect, the more the possibility of you having, data that fall within the range. So, and besides, it's a formula. It's a formula. You have been told that for mean deviation is n. For standard deviation, it can be n. If you have a large data, it's n minus 1. If you have what? Smaller data. Is that okay, boy? Is that okay? Good. So we're looking at coefficient of variation. I don't want to bore you with too much mathematics. So let's go. So let's do the same thing for B. What is the mean for B, class? The mean for B. 2.99 plus 3.20 plus 2.98 all over 3. Am I correct, class? Am I correct? Yeah, please give me the answer. Give me the answer, please. Good. That's the mean. What is absolute error here? What's absolute error here? Class, please help me. That's 3.0 and that's 3.05, 0.03. Thank you. No, there's no minus. We don't have minus. We don't use minus. There's no minus. What is the relative error Help me. Relative error. That's what? Apps. Yes, please. Yes, please. I'm with you. .05 what? Say it out. Like this. So why did you give me 3.05? If I thought you should give me 3.07, I mean 3.06. If I thought you want to approximate, you are supposed to give me 3.06. Is that what you are saying, that boy? So this 3.06. This is now 0.02. If at all you want to drop a number, you can't drop a number just like that. Unless you're testing rounding off principle, which I've explained to you. We are divide this 0.02 by 3.08. What did you get? 0.07. 0.0065. Good. So let's go. Number 3. We have percentage relative error. What's the formula for that? We just multiply 0.065 by 100%. And that will give us what? 1, 2. That's 0.65%. God bless you. 0.65%. Number 4 says you should find what? Standard deviation. And that's square root of x minus x bar. Sorry. Summation x minus x bar squared over n minus 1. Am I correct? Am I correct? So that will be what? That will be x minus x bar. So that's what? 2.99 minus x bar 3.06 squared plus 3.20 minus 3.06. Are you still with me, class? Plus 2.98 minus 3.06. This is your standard deviation over n is 3. That's 3 minus 1. Can somebody punch the whole answer and give me the final answer? Do all the mathematics and give me the final answer. Give me the final answer. Let's not waste time. We don't have time to waste. Talk to me. 0.057. Did you approximate? Okay, please tell me. 0.124. I mean, is that? Wait. You should get the same answer. This minus this squared plus this minus this squared plus this minus this squared. Divide it by 2. Divide the addition of this by 2. Find the square root. What do you get? You must divide by 2. You must find square root. Yes.
No.
0 point. Good. Let's take that as final. Number 5. Mean deviation. Thank you. Mean deviation. What is mean deviation? Square root of summation x minus x bar all over n. That's mean deviation. That means that what? Take the figures here without square. That's 2.99 plus, sorry, should I make this bracket? This is a bracket, meaning your answer, watch class, 2.99 minus 3.06. With this sign, it means if you get minus, report it as plus. Report it as plus. 3.2 minus 3.06 plus 2.98 minus 3.06 all over 3. But take note, 2.99 minus 3.06 is 0.07. Is 0.07, not minus. That girl I got minus before, do you get that now? The girl that got minus before, have you understood that now? Maybe she's offline. But do you get what I'm saying in class? So, 2.99 minus 3.06, calculator will give you minus. Disregard the minus. You must use plus, plus, plus. Over 3. What's final answer, class? Final answer. 0.097. Yes, please go ahead. I say it's just a formula. It's just a formula. No. Deviation does not have n minus 1. Deviation is n. It's just in standard deviation as n minus 1. Good. So, yes, please. Please go ahead. No. True value is only used to get absolute error. That's the end of true value. So your mean, these are the x value. Is that okay? And this is the mean of all the x value. Is that okay? So when you are doing this, is x minus x bar. There is no true value again from here like this. Look at true value. True value ended when you found absolute error. Is that okay? That's the end of true value. And when you are finding relative error also over true value, check the formula I gave you. When you are finding absolute, relative, you should say you make use of the true values. But when you are finding anything deviation, precision does not have anything. Precision has nothing to do with the true value. That was why I told you what precision is more important. Yes, hold on. Precision is more important than accuracy. Precision is more important than accuracy. If you are in the lab, you have to find the value of G in the lab. True value of G is 10 meters per second square. That's the true value of G. But all of you in that lab, all of you all gave different values from this step. But your values are wrong. Yet, all of you, your values are close to each other. Your values are close to each other. It means that what? Accuracy will not matter again. The examiner has to go and mark your precision and not your accuracy again. Because why will all of you have values that are close? All of you have values that are close in the lab, but all those values are different from the true value. Therefore, the man will not be using accuracy to judge you again. There's a problem in that lab. that has to be fixed. There might be a systematic error, majorly instrumental error. Is that okay now? So, yes, please, your question. No, mean division is not it doesn't have square root. So mean division does not have square root. I hope you didn't put it there. Where I didn't put square root here. I did not put square root here. Please, mean deviation does not have square root. That would be a big mistake. Alright, in conclusion, what's the percentage relative error? What? Hold on. For B, 0.6, I'm coming. 65. What is the percentage relative error? What is it? Yes, it's correct. 0.65%. What is standard deviation? What is standard deviation? 0.124. So let's sharply answer the question. Next question. Question 1 says, who is more precise? Who is more accurate? Who is more accurate? B. B is more accurate. Who is more precise? Who is more precise? A is more precise. Why is B more accurate? Because B has lower percentage relative error. Why is A more precise? Because A has a lower standard deviation. So, to know who is more precise, precision means how close are the values? Yes, these values are not close. 2.99, 3.20, 2.98 are not close. But for A, the values I gave you are close. That's why A is more precise. In B, the values I gave you are very close to the true value. Therefore, B is more accurate. But in A, the value I gave you are not that close to 3.08. Therefore, A is not as accurate as B. Yes. Your question, that girl. Rule of rounding off. Yes, it's a rule of rounding off which I've explained to you. Alright, let's start today's class. That's topic number 2 in your syllabus. Topic number 2 in your syllabus. Let's write. No concept. No concept. No concept. But we'll start with atomic masses. Before we now move to move. Atomic masses. Right. The topic is no concept, but we shall start with atomic masses. Yes, please, mute yourself, please. Please mute yourself. Thank you. Let me sharply ask you, can somebody tell me what an atom is? What is an atom? What is an atom? Is atom indivisible? Is atom indivisible? Is atom, no, just answer yes or no. Is atom indivisible? Yes or no? Atoms are not indivisible. So define an atom for me. Good. An atom is the smallest part of an element. An atom is the smallest part of an element which can be divided. An atom is the smallest part of an element which can be divided. It can be subdivided into what? Into three main subparticles: proton, neutron, and electron. It can be subdivided into proton, neutron, and electron. Where do we find the proton? Where is the proton found? Where is the location of the proton? We find proton in the nucleus. Proton is found in the nucleus. Can you help me to spell nucleus? Proton is found in the nucleus. Where is the neutron found? Where is the neutron found? In the nucleus. I hope the spelling of the nucleus is correct. Let me check. Where do we find electron? On the shell, or we say outside the nucleus. Outside the nucleus. That's where electrons are found. What are their masses? What are their masses? This table is very important for you in exam. What are their masses? Masses. These are subatomic particles. These are subatomic particles. So you can stop saying that atoms are indivisible. Atoms are divided into proton, neutron, and what? Electron. Where are proton, neutron found? Proton and neutron are inside the nucleus of the atom. Electrons are found outside the nucleus of the atom, or say on the shell. What are the masses of these guys? What's the mass of nucleus? The mass of nucleus is 1.6 times 10 raised to the power minus 27. No, 27. 1.67 20 kilograms. What's the mass of neutron? Neutron and proton have the same mass, 1.67 times minus 27 kilograms. They have the same mass. Both the nucleus, the neutron, and the proton have the same mass. What's the mass of electron? Mass of electron is 9.11 times 10 raised to the power minus 31 kilograms. These are their masses. You must note this table. Now, yes, please. Yes, please. Minus 31. Minus 31. Yeah, welcome. Now, yes, thank you. Instead of asking for mass, you can say, what is their relative mass? There's a difference between mass and relative masses. If you are asked for mass, these are their masses. If you are asked for relative masses, note it. Relative masses means divide all these masses by the mass of proton. Divide this by the mass of proton. Divide this by the mass of proton. Divide this by the mass of proton. That class, tell me. If you divide this by the mass of proton, what do you get? 1. That's 1. Divide this by the mass of proton, what do you get? 1. God bless you. Divide this by the mass of proton, you will get 1 over 1836. 1 over 1836. 1840. You are welcome. It's allowed. 1836 is allowed. 1840 is allowed. Or 0.005 notes. Or 0. There are three values. 1/1836 or 40, or 0.005 or 0. These are called relative masses. We must know the relative masses. It's very important. Not the same as masses. When we go to their symbols, their symbols, their symbols. What are their symbols? What is the symbol of proton? 1 to 1 P or 1 to 1 hydrogen. That's the symbol of proton. What is the symbol of neutron? 1 to 0 N. That's the symbol of neutron. What's the atomic symbol for electron? 0 to -1 electron. 0 to -1 electron. Again, another thing they can ask you in this table. They can ask you for their atomic number. Atomic number. What are the atomic number of these subatomic particles? What I'm giving you a table that contains everything about the subatomic particles of an atom. So what is the atomic number for proton? Anybody? 1. Any figure here is atomic number. These figures are the atomic number. What is the atomic number for neutron? 0. What is the atomic number for electron? -1. They can ask you again for their atomic masses. What are the atomic masses? Atomic mass are the values here. The values up here are the atomic masses. Atomic mass of proton, 1. Of neutron, 1. Of electron, 0. Those are the atomic masses. Those are their atomic masses. Let's go. How is the atom represented? An atom can be represented like this. X, Z, then what here? A. An atom can be represented as this. Class, are you done with it? I want to rub the table. Are you done with it? Okay, so I want to rub the table. So I said, how is an atom represented? How is an atom represented? Anybody? An atom can be represented as a symbol X with Z and A. Please tell me, what do we call A, class? Atomic mass. Atomic mass. Let's not use mass number. Let's call it atomic mass. Why? Because X is an atom. Mass number can be two things. Mass number can be two things. Mass number can be two things. Or we say people classify mass number as either relative atomic mass or relative molecular mass. This is how people classify mass number, even though it's not allowed. So, but this is better called relative atomic mass, or just say atomic mass. Atomic mass. If you have there's a clear difference, who can help me differentiate between relative atomic mass and relative molecular mass? Who can help me differentiate the two? Who can help me differentiate? is the mass. Hold on. Correct yourself. Relative atomic mass is the mass of an atom. Good. Of an element. While the relative molecular mass is the mass of molecule or compound. For instance, thank you again, you're correct. You know that. If you have chlorine, and if you have chlorine like this chlorine has mass number called relative atomic mass because it's an atom. But this chlorine Cl2 is not an atom, it's a molecule. Two or more atoms combined together is called a molecule. This is a molecule. This is an atom. Relative atomic mass of this guy is 35.5. Relative, are you following me? Can anybody hear me? They can hear me clearly. The code does not stop. Relative atomic mass of chlorine atom is 35.5. But the relative molecular mass of chlorine is 2 times 35.5, which is 71. This is called relative molecular mass. In short, relative molecular mass is the summation of relative atomic mass of all the atoms in that molecule. If I give you calcium carbonate, I'll be asking for relative molecular mass and not relative atomic mass. Why? This is a molecule, not atom. But the relative molecular mass will be the sum. It will be the sum of the relative atomic masses of the atoms present. What is the relative atomic mass of calcium? 40. What is the relative atomic mass of carbon? 12. What is the relative atomic mass of oxygen? 16 times 3. So relative molecular mass is the sum of the relative atomic mass. So let's go on. This Z, what do you call it, class? Atomic number. What's another word for atomic number? Proton number. Proton number. Proton number. Proton number. What's another name for atomic mass? Another name for atomic mass? No. It's what? Say it again. No. It's called nucleon number. It's nucleon number. Number of proton and number of neutron in the nucleus of the atom is called nucleon number. Number of proton plus number of neutron in the nucleus of the atom is called nucleon number. So this is your atom X. Who can tell me, how do we find the number of neutron? How do we find the number of neutron? Yes, mass number minus what? Atomic number. That's it. Relative atomic mass minus proton number. This is the number of what? Neutron. Who can differentiate the following? Anybody? Differentiate the following for me. Right. Differentiate the following. Isotopes, isobars, and isotones. Who can differentiate topes, bars, and tones? Who can help me differentiate isotopes? Yes, please. Yes, please. What do you call isotopes? Say. No, hold on. Define it, let me hear clearly. One person. No. You say isotopes are atoms. No. You didn't finish this thing. No. Come again. God bless you. Isotopes are atoms of the same element. Very, very important. Isotopes are atoms of the same what? Element. They must come from the same element. With the same atomic number, but different mass number. I've told you already. We call them mass number. I've told you already. You have the same atomic number but different mass number. What does that mean? Hydrogen 1, hydrogen 2, hydrogen 3, 1. They are all atoms. They are all atoms of the same element, hydrogen. Chlorine 35, chlorine 37, 17. They are all what? Atoms of the same element, chlorine. They are atoms of the same element, what? Chlorine. Also, carbon 12, carbon 13, carbon 14, are also what? Atoms of the same element, carbon. Very, very important. So, who can tell me what causes isotopes? Why do isotopes exist? Anybody? No, never. In fact, number of protons are the same. What exactly causes? God bless you. Put it down. Isotopes are caused due to the difference in the number of neutrons. Isotopes are due to the difference in the number of neutrons. Why do we call these isotopes? Because all of them are different neutrons. The only reason why, look at the board. See the board. The only reason why here is 1, here is 2, here is 3, why their masses are different. The only reason their masses are different. What makes masses different is because the number of neutrons is different. Because atomic mass A is actually Z plus A. Z plus what? A. For all of them, they are all 1. That's their Z. Their Z are 1. Their atomic number are 1. What makes the atomic mass be 1, 2, 3 is because in this place, in the first hydrogen, what's the number of neutrons in this hydrogen? Check where? 0. What's the number of neutrons in this hydrogen? What's the number of neutrons in this hydrogen? Answer is now 1, 2, 3. It's because these values, number of neutrons are different. That's the reason we have what? Isotopes. Right, tell me. The extent Right. The extent, write it down. The extent to which the isotopes of an element exists in nature is called dash. Who can feel it? I will come for 2 exercise books. That girl, correct it where? No. Relative abundance is relative abundance. The extent to which isotopes of elements exist in nature is called relative abundance. Don't say abundance, say relative abundance. So take note. Meaning. To what extent does carbon-12 exist in nature? Meaning, what's the percentage of carbon-12 in nature of the whole carbon we know? What percentage of carbon-12 exists among these? Just like in the world, there are males and female. What's the percentage of male? What's the percentage of female? That's called, what's the abundance of male? What's the abundance of female? So what's the abundance of carbon? How much carbon? We know that when we say carbon can be 12, 13, or 14. But to what extent does carbon-12 exist in nature? How much carbon in the world is carbon-12? How much carbon in the world is 13, is 14? The extent to which any of these exists in nature is called relative abundance. Note. The most abundant is usually the one with lower masses. Write it down somewhere. I come again. Hydrogen 1, 2, and hydrogen 3. Now, what is the most abundant of these 3? Is hydrogen 1. The lower the molecular mass, the mass number, the atomic mass number of that element, the more abundant that element. Between 35 and 37, tell me, which should be more abundant? Chlorine 35 and chlorine 37. 35. God bless you. Between carbon 12, 13, and 14, who is the most abundant? Carbon 12. The lower the atomic mass, the more abundant it is. Also note, the more the atomic mass, the more likely for that element to be radioactive. The more the atomic mass, the more likely the atom to be what? Radioactive. These are bullet points you need. I've answered like 5 questions in the exam already. Yes, please. The lower the atomic mass, the more abundant that isotope will be. Is that okay? The more abundant. And the more the atomic mass, the more likely the atom will be what? Radioactive. The more the atomic mass, the more the possibility of the atom being radioactive. Because radioactivity is caused as a result of increase in the number of neutrons of the atom. I come again. What causes radioactivity? Radioactivity is as a result of the increase in the number of neutrons of the atom. When the neutron to proton ratio of an atom is too large. It's too what? Large. When you have more proton than neutron, atom tends to be radioactive. Atoms tend to be radioactive. Let's come back. What are isobars? Right. Isobars, right. Isobars are atoms of different elements. Watch this. Isobars are atoms of different elements with the same atomic mass, but different atomic number. Oh, I left something out. Under isotopes. Can I just say it and write it somewhere? I left something out under isotopes. Can I say it and you write it somewhere? Should I say it? Yeah, put it down. The relative atomic mass of every element is usually decimal or fraction. As a result of the presence of isotopes. Let me make it a question. Question. Why is the relative atomic mass of every element never a whole number? Why is it not whole number? Why is it decimal? Why is it fraction? Why is the relative atomic mass of every element never a whole number? Always fractional, decimal. Why? Answer: because the presence of isotopes. Very good. Let's write. Let's look at isobars. What are isobars? Atoms of different elements with the same atomic mass but different atomic number. Give me an example of isobar. Anybody? Say it again. Carbon 14, 6, nitrogen 14, 7. God bless you. That boy. You can see same mass number. Watch it. With the same atomic mass. They are different elements. This is carbon. This is nitrogen. They are different elements. Carbon and nitrogen. But same with different atomic number. Atomic number must be different. And that's a must. Who said that atomic number of every element must be different? Who says so? Which scientist says so? No. Is what? Mostly said the chemical properties of every element. The properties of every element is a periodic function of the atomic number. God bless you. That's mostly. Is that the property of every element is a periodic function of its atomic number. Every element must have a unique atomic number. Because carbon and nitrogen are different elements, they must definitely have different atomic number. Another example is argon 40, 18. Is it 18?
Okay.
And And which one? Is it argon? Calcium is what? 40, 20. Argon, Ar, calcium. Same mass number, different atomic number. Good, thank you. What do you call? Past 10. I mean, it's past 10. Eh? Wow, I think it's past 10 already. Okay, I was told it's past 10 already. So let's quickly do isotones. What are isotones? Anybody? They are what? Atoms. They are atoms of different elements. Atoms of different elements. They are atoms of different elements. With what? With the same neutron number. With the same neutron number. With the same neutron number. But different atomic number and atomic mass number. So they are atoms of different elements with the same word, neutron number. If you calculate their neutron, it will be different. Let me ask you, how many neutrons in this carbon? How many neutrons in this carbon 14-6? 14 minus 6. Here come. How many neutrons are in this place? 14 minus 7. How many neutrons are in argon? In argon. 40 minus 18. How many neutrons are in calcium? 40 minus 20. Good. If you calculate for two elements and the neutron numbers are what? The same, they will be called isotones. Give me examples of elements that we can call isotones. Give me an example. Carbon 14 and what? Oxygen 16 and what? 8. You can see what? Number of neutron here. Number of neutron here is what? 14 minus 6. That's 8. Number of neutron here also is what? Is what? 16 minus 8. That's 8. We call these guys what? We call them isotones. They are called what, class? Isotones. Right, paragraph. Last statement for today. Last statement for today. Right. Last statement for today. The relative atomic mass. The relative atomic mass. The relative atomic mass. Relative atomic mass of an element. Of an element is measured analytically. Is measured analytically using a dash. Using what? Anybody? God bless you. Using what? The relative atomic mass of an element is measured analytically using a dash. Using what? Anybody? Somebody has answered me in the physical class here. Somebody has answered me in the physical class here. Using a mass spectrometer. Using a mass spectrometer. Tell me you didn't Google it. And you didn't ask ChatGPT. Tell me it was not Googled. Alright. Using a mass spectrometer. Our next topic. Right. Right. Relative atomic mass and mass spectrometer. Are you guys with me? Relative atomic mass and mass spectrometer. Alright, we stop the class here today. I hope you enjoy the class. Yes. So, I try, once the school resumes, we are giving the school next week to coin for training. Once the school resumes, physical class is far better than online class. We achieve much more in physical than online. So once you resume, join us. Join Adjectival tutorials. And you will not regret doing that. Is that okay, class? Join Adjectival tutorials and there will be no regrets. You have no regrets. Alright, thank you and good morning. Yeah.